So let's take a look now at multiplication of rational expressions. So we're in your workbook, page 403. And so just a reminder then on multiplying fractions. So multiplying rational numbers, the general rule, of course, is multiply across. So 7 times 1 is of course 7, and 10 times 5 is 50, and hopefully there's nothing more that can be simplified. If there is something that can be simplified, obviously you want to do that, but ideally, especially when it comes to multiplying with rational expressions, you want to get rid of those factors first. So rather than multiplying across here to get 45 over 60 and then trying to reduce, ideally we're trying to reduce first. So 9/10 doesn't reduce, 5/6 doesn't reduce, but we know that this is exactly the same as if you would switch them around and had 9/6 times 5/10. It's the same thing as 45/60, in which case we're dealing with 3/2 times 1/2, and multiplying across, it is 3/4. So with rational expressions, you guys have seen how much writing we have to do already, so the thought of having to write everything out again and switching them around isn't all that appealing. So of course there is always the option of saying, hey, if I had 9 over 6, that would be the same as 3 over 2. If I had 5 over 10, then that would be the same as 1 over 2. And so then we can see that it's 3 times 1 is 3, and 2 times 2 is 4. Of course, things can get a little bit messy, so make sure that you are as neat as possible, and if it means that you're writing things out to show a middle step, then definitely do so. So multiplying of monomials is where things can get really, really messy for sure. So keep track of things, especially if you're dealing with exponents as well. So taking a look right here, we've got 12 over 4, that can be reduced to 3 over 1, and then we've got a y here and a y here, and then the z here can be reduced with one of these z's here. And so now I've just got 1 in my denominator, so I don't need to show that 1 in the denominator, and essentially we've got 3x times 3xz, so that'll be 9x squared z. Don't forget your restrictions. Whatever was in the denominator needs to be stated, so we know then that y cannot equal 0 and z cannot equal 0. Looking at example, the second one, part B then, so I can be looking at numerator, or I could be looking at, numerator, denominator in the same fraction, or numerator, denominator in the other fraction. So usually easier just to do in the same fraction to start with. So I've got a b squared and a b squared. I've also got a c to the 4th and a c, so that leaves me with 3 more right here. And then I can also take out a factor of 5 here, so that leaves me with 7/8. If you're feeling that it's starting to get messy on you, then feel free to rewrite it. So we've now got 5a squared c cubed over 14d times 7b over 8a cubed c. And so then we're looking at, let's change the color here, so 7 over 14 is 1 over 2, and we can also take out this c with one of these, so it's c squared, and then a squared and a cubed, so that leaves me with 1 more a here. So I think that should be it. So our final answer then is 5c squared b, or keep those in alphabetical order, so 5b c squared over 2d times 8a, so that would be 16 AD, and whatever variables were ever in the denominator, so that is all of A, B, C, and D. So our restrictions then, of course, are A cannot equal 0, B cannot equal 0, C cannot equal 0, and D cannot equal 0. And it's good general form just to write out all of the variables separately as opposed to saying all of A, B, C, and D cannot equal 0. So the same thing then when we get into working with binomials. I mean, in fact, you might find the tougher part about it is now having to potentially factor your polynomials, but it's definitely a little bit neater. We don't have all of these numbers getting crossed off and getting confusing right there. So let's take a look here. They've already given it to us in factored form, which is awfully nice. And so we've got a numerator and denominator, so an x plus 1 and an x plus 1 and an x plus 3 over an x plus 3, and that's just it. So remember, these were all just 1 over 1 when we canceled those out. So we're left with just 2 on the numerator, and the denominator we've got x times x minus 2. And definitely do not cross off those 2's. It's x minus 2 that is the factor. So stating our restrictions then, x cannot equal, and again trying to keep them in some kind of an order, preferably in ascending or descending order. So we've got -3, -1, 0, and +2. Okay. Looking at the second one, I'll just switch a color here. So we need to do a little bit of factoring. So we've got a common factor of 4, so that leaves me with x plus 4, and common factor of 7, leaving me 2x minus 1 times, conveniently, 2x minus 1 over, convenient again, x plus 4 all squared. And so with that, we know we can cancel out 2x minus 1 over 2x minus 1 and x plus 4 with one of these x plus 4's. So the 4/7 does not reduce, and so we are then left with 4 over 7 times x plus 4, and our restriction, taking into account all factors in the denominator that may have been canceled out, so x cannot equal -4 or 1/2. Okay, so example 4, example 5, all comes down to factoring. So again, remember to double check, triple check your factoring. So hit pause, go through your factoring, and hit play again once you're ready to go. So we're now factored, and again, reminder that if you're having troubles factoring, factor the ones that are easiest to factor and then start using those ones as clues, because again, as you're learning this, the likelihood of something being able to factor out, having a common factor, is extremely likely. So use those as a clue. So when we get to that next one, I'm going to probably factor this last one last. I'll probably take out a factor of 3, but after that, I'll factor that at the end and take a look at what the other ones look like as a big clue. So looking back at class example number 4, so we have m squared and m, so we can cancel off one of those m's. M minus 2 and m minus 2. We can only take one numerator with one denominator. So I could either take this one with this one or that one with that one. But we definitely can't take the two numerators. So denominator and numerator might as well take one on top of itself, and then m minus 3 and m minus 3. So that then leaves us with 2m times m minus 2 over m plus 2. And for somebody, oops, I forgot about the 3, sorry. And for somebody who might be thinking, oh, hey, can I factor out a -1? But no, you cannot, because these are not exactly opposite. The 2's are opposite, but the m's are both positive. So you cannot factor out a -1. So this is our answer. No need to distribute that back in. And we just need to do our restrictions based on those factors that were in the denominator. So we've got 0 here, 3 negative 2, and positive 2. So again, in some kind of an order, so I generally do things in ascending order. So I've got negative 2 and 0 and positive 2 and positive 3. Okay, so taking a look at class example number 5, so hit pause once, and once you're done factoring, you can come back and hit play. Okay, so taking a look here, so I factored out, in the denominator here, I factored out a common factor of 3, and that 3's got to stay there as well, because that's what it equals. These are expressions, they're not equations. It's not set to 0. I can't divide it out, so that 3's got to stay. Same thing in this numerator here, I factored out a common factor of a. So knowing that I still have those polynomials to factor, I needed to do another step, but I could already see that there's a common factor of a plus 5 and a plus 5 that I can factor out, so why write them again? So just wrote out the a plus 3 in the numerator, factored that denominator, and factored that difference of squares. So now we can see that we've got a plus 3, and a plus 3 is 1 over 1, and 1 minus 2a, 2a minus 1. Now these are our exact opposites. Positive 1 minus 2a, positive 2a minus 1. So again, we can factor that. Instead of 1 over 1, we're looking at negative 1 over 1. So that then leaves us, oh, and I've also got a common factor of 1 plus 2a. So here we go. So not much left here. So in the numerator, it's just negative 1a or negative a. In the denominator, it is just simply 3. And our restrictions, not forgetting about that a plus 5 that I crossed off right from the beginning. So I've got negative 5 for that one, negative 3 for the a plus 3, and then for the 2a plus 1, cannot equal 0, a cannot equal negative 1/2, and for this one, 2a minus 1, a cannot equal positive 1/2. Excellent. So on to your assignment.